Welcome back. In this video, we will talk about concurrency. Concurrency is about multiple things happening at the same time in a random order. It provides a built-in support for concurrency. Because of this reason, people choose Go over other languages. So let's see why we are interested in concurrency and why we need to think about concurrency while implementing a software. Let's talk about an example of addition. This is a simple addition function. It takes a slice of integer as input. It loops over those integers, computes the sum and return the sum. If I pass a slice of million of number of integer as input, then it is going to take more time and compute the sum. So question is, can we make the program run faster? Before we talk about the code, let me explain the situation on my computer or the computer configurations. I have multi-core processor. When I run my add function to compute sum of the slice for the millions of number, it is going to run on one core, whereas the other cores are still idle. Can we make a use of other cores to make our computation faster? One way would be to divide the input slice into the multiple slices and run add function on each part of the slice in parallel or different core. In this way, we will be doing our computation in parallel, which would make it run faster. So here is our add function, which is we are passing the slice of number as an input and it returns sum as an output. So if I pass or use this method to do the calculation for millions of number, it will definitely take more time. Now let's go and see the function generate number. This generate number method is being used to generate a millions of number. Now let's see the main method. What does it do? It calls the generate number method, gets the slice of numbers, and then we are passing that slice of numbers here to the add method. That is our sequential method, this method. And after returning the sum, we are printing that sum and how much time it took to calculate the sum. That's a one way. And second, we can execute the computation in parallel. So we can create a multiple concurrent thread and then execute the sum and append the sum, add the sum of all the threads into a sum variable and return a value here. Let's go and see how add concurrent function is been written. So again, add concurrent function takes the input slice of an integer data type. Then we are getting the number of CPUs number of cores we have available, and we are saying that okay, I want to utilize all the cores available, and then I'm just using the length and slice all the numbers from the slice, and then I'm looping over the number of slice. Then I'm adding weight group every time I create a slice or new count, incrementing the counter for a weight group, and I'm using the go keyword to generate the new thread. So go and function, and this function takes the slice of a number, and then I'm saying defer weight group done. Once this thread is done with the computation, defer method will be executed to intimate that the thread has completed the execution. So now for loop is going through the set of numbers available in the nums slice and add them and update the atomic number sum. Weight group intimating that we have to wait for the completion of all the threads. We will get the exact time and the sum. So after execution of this program, I found that the sequential computation took 13 milliseconds, whereas concurrent took 5 milliseconds. Thank you so much. We'll continue on the next video.